Ah, and yo, big man, how come the light bulb gets hot when it's on? Are you dumb? Why are you touching the light bulb? It gets hot because of something called the heating effect. When charge passes through the wire, it collides with the positive ions, and due to friction, heat is released. Aye, safe, G. Bro, what are you doing now? I'm trying to dry my towel, innit? Instead of using the dryers, man's using the light bulb. Saves electricity and that. You know me, man. I got that big brain stuff. Today we're going to be looking at something called the heating effect. Now in the last video we learned about current and resistance. If you're unsure, you're not confident about what these mean, I advise you to go and watch that video before coming into this one. Now we need to understand that some components do not obey Ohm's law. And what that means is the voltage is not always proportional to the current. That's not true for all components. With resistors and variable resistors, they will in your questions that will always be the case. But if we look at something like a light bulb, you can see that voltage is not directly proportional to current at all. And why is this? We talked about last video. We had this wire, and we had our positive ions in the wire and electrons flowing through the wire. And we talked about how when the electrons flow, they collide with the positive ions. And that's what the resistance in the circuit is. They rub on each other. And when they collide or when they hit, there's obviously going to be friction between the positive ions and the electrons. So therefore, due to friction, heat energy is released. And in the last video we talked about the effect of temperature on resistance. As temperature increases, we know that the positive ions vibrate more. And as they vibrate, there'll be more collisions. And that makes sense if you think about it. As you move your hands, imagining these are positive ions, it's a lot easier, there's a greater chance of electrons colliding with them. So therefore the resistance increases. Now if you're supplying a current, if you supply that current for a while, you're going to get electrons colliding with the positive ions and the positive ions vibrating more, and due to friction heat is released and the positive ions vibrate even more, and the resistance increases. We saw in the last video that for constant voltage, even if you use the V equals IR formula, if this is constant, as resistance increases, the current must decrease. So therefore, current decreases. This is known as the heating effect. And this is what you'll see in components such as the light bulb. If you look at the light bulb IV characteristic, we know that, in this case I'm going to put voltage on the x-axis and I on the y-axis. We know that as we supply a greater voltage, the current will increase due to Ohm's law, but as the current increases, we know that due to heating effect, the resistance will also increase. We have seen in an IV graph like this, the gradient is equal to 1 over the resistance. So as the resistance increases, the gradient should decrease. If you look at the IV characteristic for a light bulb, you will see it looks something like this. As the voltage increases, so does the current. But due to the heating effect, the positive ions in the light bulb will vibrate more, creating greater resistance. So there gets to a point where as soon as you apply more and more voltage, the current increases by a lower and lower amount. And that's why you can see here that the gradient, which is equal to 1 over R, decreases as voltage increases.
I advise you to go look at some practice questions in order to help reinforce what you've learned today. It's a good way to understand how to apply the content and the equations. Please make sure to subscribe, like, and comment, and feel free to watch any of my other videos if that will help you with your physics course, and good luck for your future.